my talk is a bit more like ontologies for dummies. And so I hope to catch up with, I mean, not supposing anything here, right? But I hope I give everyone the chance to more or less follow a bit and maybe get some more aha moments that we'll get to talk about in a second. So first of all, this is how I structured this basically for everyone to remind you what is the knowledge graph used for. I mean, there's the answers right after, but the talk goes a bit longer anyways. Then like what is the kind of information we can make accessible through that, and how like the information we're gonna make accessible. And then the question, how do we want to make this information accessible? And then finally, the big question, like how do we build this system which more affects questions of collaborative working environment, which is also something we've spent like a lot of time by now thinking about. But once you really learn and start to interact with us, you will notice that we can actually only decide this together with everyone involved in the project, like for its end. So first of all, and this is where Ontologies for Dummies starts, let's look at Tabea. Tabea has research data, and she does not want to structure this in a tabular way. Why doesn't she? Or in a relational database way, which is what you see in the top left corner. Because obviously it will be super hard for Tino to understand what her data means, because basically we all have Excel tables and we structure them however we want and imagine, and no one's ever able to really understand this afterwards anymore. So still, she wants to pass her data, which is this box, to Tino. And this is basically what we are developing here. We're developing a way for universally retrieving information. It does not necessarily need to be data only. It can also be some kind of logic, deduction, transitivity or something, but some kind of information we want to pass to others and make accessible. We make this accessible mostly, and this is something which you should get familiar with early on, the so-called query. I cannot say, there might be other ways of talking about this, but something that is always like coming back and we're circling around it, the big question, like what is the query? What do we ask our system? And I want to make you sensitive for this, because it will also be one main challenge to you building your systems, trying to really think in the way the query works, basically, because the query is the way we ask our system stuff. And what you see here on the top right is the aha, it's your aha moment. The knowledge graph stores the information different to our traditional ways. So how does it store the information? It's like in a way what Harald just showed, but I will I will try to show this from a different perspective, and then also like how we proceeded so far. So once we have the query set up to retrieve our information, basically you should understand that more or less, I mean, there's always obviously limitations to a sentence like this, but more or less most or every system will work over the query to retrieve information from our graph afterwards. So this will be, I mean, you've probably noticed by now that we work with Pyron and SimStack. These will be scripts inside, like that run inside these frameworks. But this also might be generally Jupyter notebooks or any other external software, or a GUI where your user says, give me information. In the end, at one point, most of these questions or will have to be translated into a query that is structured and that is just able to retrieve the right piece of information from our system in the bottom. So the second aha is the knowledge graph can return predefined information, maybe not like exactly predefined information, but information that is defined, or pieces of information that are defined and structured in a predefined way. It cannot, however, solve all problems on Earth. So sometimes there is this common or little misconception that people just assume you can use the graph for everything in the future. And maybe at one point humanity will be able to do this, but we are not there yet, and we will not be probably in the scope of this project. So please keep your expectations in checks. So how does this actually work? The ontology structures the graph according to the way we model it, though. So you just saw that it is able to retrieve information, but how do we need to set up this graph to retrieve the piece of information that we want? So for everyone to understand, that is obviously, this is natural language, is not how you would define a query, but in a logical sense, a query could be something like, give me all nominal parameters of tensor test with ID 1, 2, 3, the attention, people within the audience will already notice that I'm trying to get into the direction of material science here more and engineering. So basically, inside your graph, you have something called the terminology, which was just introduced by Harald as well, where you define your system in a structure, your terminology and your relationships in a structured way, which then can be used for so-called instances to refer to. And this distinction will also be something that accompanies you all the time from now on. So please be always sure, once you're talking about the distinction, if you're talking about the terminology development, which is something we need to do commonly and jointly within everyone involved in a way, or if you're talking about the instance level, where there is then like one tensile test instantiated from many classes of tensile test, and so it's an instance. And so this query, for example, could return information, as is shown here, which would give you the structured information back that you instantiated here. Please be aware that this is obviously, there's no formal correct ontology. This is more for you to understand more or less the difference. So we have one level where we set up the structure, and we have one level where we set up the individuals that are tied to the structure, obviously. Now, something else that you notice here is if we haven't defined concepts, that is why we always talk of concepts, words, etc., in our terminology, and accordingly in our instances. Obviously, you will not be able to ask your system for this term or these concepts. So you could not ask a structure like this for like the question, how high are the pyramids of Giza or something? How would it know? But this is something you must keep in mind once you're modeling, because this is sometimes not clear, and we run circuits because we don't force ourselves to think clear about this also before starting. So the next aha here is we must be clear about the information retrieved by a query at best before working on it, okay? So basically, Harald already mentioned, we have this core ontology thing, and this is like really the strategy that we're now getting into of PMD in the light of ontologies. We have this core ontology that the PMD must more or less agree on as a whole, and which will give you concepts just as the ones on the left, which are common then. And there is the application ontologies, which are then supposed to point to these concepts with their specialization. So this is always like a parent node, and it diverges into different subclasses, which are still like all pointing to the parent node above. So now you will all get to know this way better than you can see it here. This is like only an extract or a glimpse of this core ontology, of which the main purpose will be to provide concepts that all your concepts in your use cases will be able to be subclasses of. So we need to provide common roof concepts that the specialized concepts can point to. So basically, you would see here that there is a process, and then the tensile test would be the specialized concept which can point to the process, because the process is the parent class. So what you see here is basically the core ontology of the PMD as it is right now. I cannot stress enough how we are still at the beginning of this. So please, everyone, be easy with each other. We are still learning. We have taken the time now, invested into this. We think we're doing it okay, but there will still be iterations necessary to improve what we have so far. So when it comes to the status quo, which we purposely call only version 0.1 for everyone to calm down a little, we have it available since yesterday under materialdigital.de/download. You need to have an account on our Material platform to access this, and there should be a zip file and you can download it. So everyone getting into this and everyone being more experienced, you should know you can open an OVL file, for example, in Protégé, but you can also visualize it with different tools. This will be a learning period for everyone from now on, and so don't be disencouraged if you realize you don't understand this all right away. So how do you start with your own process of developing your application ontology? And actually, after a year or so that we now worked on this in the scope of MaterialDigital, I think that the process could be pretty straightforward if you do it correctly. Just as straightforward that you could put it into a comic. So this is what I tried to do here. And also with some use case, which is maybe a bit off topic, but maybe a bit like more relaxed for everyone to understand and follow through. So basically, Tabea now wants to, for example, digitalize the process of baking her favorite, so grandma's favorite cake. So how would you start with this? And obviously, the cake now is supposed to represent your own use cases in your projects, because this is supposed to show you how proceeding with this is rather clearly straightforward if you do it correctly and not just start working on it without having all the preconditions met, like thinking about the queries, etc., etc. So how would you start? In a simplified way, of course, you would start with the process discretization. You would ask yourself, like, what is the processes that we want to represent? Obviously, you don't do this alone. So also Tabea is talking to an expert who is Arno the cook. And then you would always go on to specify more, but to stick to the decisions you've made in the past also. For example, you would decide that the process discretization of cake making is composed of stirring or making the dough and then baking the cake. And then obviously there is the analysis process in the end where you taste the cake and eat it. So basically you would, for example, proceed by defining that for all these process steps, you have defined a set of parameters that you want to monitor in the future. And now be aware that these parameters, they define your system boundary. And also everything, as I just said, everything beyond that, you will not be able to represent in your model. And this is why we must be so careful with like how we start modeling. Now this goes on, and they defined the system in this way. So this is then the T-box, which can then be instantiated each time her grandma, for example, makes a cake, and she can instantiate the data for all the parameters that she defined up here. Now, this would, for example, be the grandma cake application ontology, because this is about the grandma cake. This would be the general baking core ontology, because here we have processes which are reoccurring over different cakes, okay? And this here would be the so-called A-box, where you make assertions based on the terminology that you introduced in the T-box. Now, with all this information gathered, what would be an ontology competency? This is also something to think of while developing this, like what competency is my ontology supposed to have in the end. So one could be, of course, like give me the sweetnesses and according vanilla origins of all cakes. And then, for example, you could use this in an outside evaluation analysis with scripts for making correlations or training your machine learning model about like, how do I get the sweetest cake or whatever. To sum this up, one cannot stress enough how light but new use cases should start out there onto modeling. So this is seriously, keep this at mind, because we always turn out with like too sophisticated approaches. We realize halfway through that we need to lower our expectations for our representation, just because you always run into this problem that you notice, oof, to regard this aspect, I actually have to model the entire world. It's just, you run into this problem, and you will do it just as well. At the same time, please note that in the end, like using the ontology as a data container, as this would be the case here, is only like the lightest or the simplest way, which is actually for its usage. And we want to go actually far beyond that over time. Now, finally, and this now really goes into our joint strategy, how we want to do this. We need to find ways how all these projects can work together while still developing more or less their own thing and also introducing their own expertise into this joint system. So I have one other kind of not so nice information at this point. It's just that the one fit for all solution for ontology development is not there on the market. Maybe Google has it internally. I wouldn't know. But at least I can tell you that right until now, we have to work with a stack of tools which enables us to do more or less what we want, which is sometimes a bit cumbersome though. So first, like this is how we did the process so far. We start by like the megaphone is supposed to represent talking. You need to talk a lot. And then you start by experts putting down their expertise in standardized descriptions, which you can see like as an impression on the left here. We use GitLab for this because it's perfect for versioning. And you can, for example, describe recurring concepts. You can link concepts in a semantic way, like you would say this is based on this, etc. But you do this in a way like you would talk to someone or explain it to them. You go on then to extract this information. This should be someone who knows their stuff about ontologies, at least in a way. Start working and modeling. I mean, Protégé is the go-to tool that you use for this. Which, I mean, you can see here how this turned out. So basically, this was original gauge length. This would be the natural language description of it. And then here in the end, it turns out as a quantitative metadata measurement has measured gauge length. So this is basically how these concepts and these ideas evolve over time, going through different hands. So in the end, and this is also something where we need to catch up a little, we are working on a PMD GitHub currently, where you would also be able to share your progress and your current versions. So this could be the area where we review each other's inputs also. And then in the end, once you have your ontology developed, it can be the basis for a triple store. I mean, we work a lot with Blazegraph, but we know that there's others as well, where you host this as your data graph. And then obviously, and this, I mean, Henk will talk a bit more about this. We have a Docker, or the aim is to provide a Docker environment in our PMD architecture, infrastructure that hosts these graphs, which are then queryable from there. And obviously, this entire process iterates all the time because we will not be done so quickly with all this. But generally, I hope this gives you an impression of how this environment could work. Generally, it's important the PMD suggests a tool stack, but we must define jointly what suits us. Again, here, we cannot dictate anything. We can make like sophisticated suggestions, but we are based on your input and your feedback also in the future when it comes to how different methods suit you, what could be improved, etc. So generally, I want to close my talk with this last call. So this is also NFT MAT work, which is closely related to our efforts. Let's work together to make this possible, but also please, this could be seen as something like a charter of our collaboration. Be patient with each other. So what we're doing there is in a way unprecedented, and it's new for many, and you will notice that there is misunderstandings all the time, and you need to talk to each other with different disciplines. There are language barriers. There are now more than ever, there are like geographical barriers, etc. So I call on everyone to like see this more as a joint thing. Also, I mean, that results from this, but higher expertise in several people is your advantage and not someone else's failure or disadvantage. And also generally, please, if you don't like something, try not to complain, but proactively contribute and solve and add your own ideas, because basically no one of us claims that we know everything perfect when it comes to the best approach. So in the end, but I will provide this with the slides. Here I have a little step-by-step guide to the questions to ask yourself, which are more supposed to guide one through the modeling a bit more like pragmatically.